Very humbled to be among you guys today. Thanks for having me. I'm the owner of Phoenix Habitats. We are a habitat restoration firm, and we're exploring restoration methods through regenerative soil management. So we do conventional field services with our restoration technicians. We do spraying, mowing, and planting. We use all electric hand tools except for large diameter tree thinning where we need some big saws. And then we also do soil testing, and we're starting to plan and implement projects and trials on projects with regenerative approaches and herbicide reduction. And so the question that I was asked today is, how do we build climate resilient soils to support native plants? And it's still an open-ended question, but I have one piece of advice. Go ahead. So yeah, we think we know a little bit more about this question after doing a couple of years of soil testing. But one thing that I wanted to bring up today is maybe a word of caution that we might not want to go all in on commercially produced bagged fungal inoculant products. Right now, there's no scientific consensus on the viability or efficacy of these products. There's a meta-analysis with results from global worldwide applications. They found there were 80% failure of the fungal spores due to the preservation process in the bags, and also that less than 10% of roots were actually colonized beneficially. A lot of the results that we see in the first year after using these inoculants is usually a false positive from the included fertilizers that are in the bags. And so we've surveyed using microscopes some of the most popular mycorrhizal inoculant products for endo and ectomycorrhiza. And usually what we find are monocultures of some of the most aggressive generalist fungal species. And these are the species that are commercially viable to produce at scale. They reproduce extremely rapidly, and they're very tough and can actually hold inside of a preserved bag environment. Still, we see reduced diversity in the bags, usually 1 or 2 species rather than the list that they advertise of 15 species. This is a picture from our microscope at 200 micron scale showing Rhizophagus irregularis, one of the most commonly found species worldwide of endophytic arbuscular mycorrhizal fungi. And when we see these species in our soil testing for both native and invasive species, we usually find that they are rapidly producing and creating monocultures associated with degraded soils and invasive plants. So the previous image that I showed is not an uncommon image for us to find with reed canary grass or velvet grass. Very, very simplified microbiomes, bacterially dominated, and 1 or 2 species of fungal spores producing monocultures in that environment. In the last couple of years, we've taken averages of all of the native and invasive plant samples. So this is original data from our data set, and we find that on average, invasive plants actually have 30% more fungal biomass than native plants, and it's because native plants are so much more rich in diversity, and they have other microbial demographic groups that are associated with fungi, whereas invasives usually proliferate these aggressive generalist fungal species. So there's climate resilience implications for this. Aggressive generalist AMF and ectomycorrhiza can actually deplete organic matter, and they do this by solubilizing organic matter and converting it into available nutrients. They do this on a much more rapid time scale than we see with diverse fungal populations. They flush the soil with available nutrients, which leads to rapid weedy plant growth. usually also with non-native species. By depleting the organic matter and increasing soil nutrients, they can destabilize the soil environment itself and create less of a buffer for microbial specialists to persist. So that can reduce system diversity and soil stability, and then they can actually compete with and break fungal connections with native endo and ectomycorrhiza. They do this by doing all of these three things, and then also direct competition for host spots on plant roots and outcompeting other ectomycorrhiza. This is a study that just came out in 2025. A group actually inoculated with commercial bagged inoculants to see what the effect would be on garlic mustard. They hypothesized it would deter garlic mustard growth as a member of the Brassicaceae family. It actually fueled garlic mustard growth by greatly increasing soil nitrogen nutrient availability. And so our conception of climate resilient soils at this moment is diverse microbial communities with stable organic matter and net carbon sequestration over time. And I know there's a lot more to talk about. This is a lightning talk, but we are exploring regenerative management strategies informed by soil testing, and would love to just use this as a conversation starter. Yes, so Nora was saying there's arbuscular mycorrhizal fungi and endomycorrhizal fungal ectomycorrhizal fungal spores basically everywhere. And if you improve the soil so that it's able to support plants through, cover cropping or other holistic methods, those fungi will start to proliferate and create a more balanced ecosystem rather than injecting with these aggressive generalists. Yeah, that's called microbial transplanting, sort of like a fecal transplant in humans. And it's very, very effective at introducing the microbiome that's successful in one area into a new plant. And one of the best ways to inoculate is to do that for the plants that you're going to install on a new site. You can, if the plants have soil around them, you can use reference soil and inoculate the soil for the new plants. You can also create a seed wash and cover the seeds in that microbiome and inoculate through seeding.